So today we're graphing, given an equation, coming up with the graph. I'm going to show you the, whoops, not that. Here's the base sine curve. This is what it looks like. Those 5 points are what we're going to talk about first. They are the points that you are looking to find, okay, in all circumstances. And if you're doing cos, you're looking for those 5 points. Okay, that's kind of the expectation here at Galt. I can stretch it, I can compress it, I can flip it. Okay, but the standard amplitude or A value, is 1. And that's what we're going to talk about is the A value, the K value, the C value, and the D value. That's what it's all going to boil down to, as you can see on the side here as well. I can compress it horizontally or stretch it. And I can move it left and right. And I can move it up and down. And then some combination of all of those transformations will give us all the different versions of the sine curve and the cosine curve. And we talked about this. It's really important to recognize that if I change the max to 2, that didn't change the amplitude. What is the amplitude of this function? Okay?
1.
It's 1. What is the amplitude of that function? It's also 1. Why would somebody think that the amplitude is 2? Because the max is 2 and the amplitude of the base function, the amplitude is 1 and the max is 1. So you think, oh, the amplitude is just the max. No, that is not the relationship. The relationship is the distance from the 0 line to the max. And if I just drag it up and down, I'm not changing that distance. It's when I stretch this that I do change the distance. And now it's taller from the 0 line. And again, it's always symmetrical, as we were just talking about. How far it goes up should be the same as how far it goes down from the 0 line, which is just the middle. I've heard other schools call it the axis. So if you've done this somewhere else, they maybe didn't call it the 0 line, they call it the axis, or who knows what other names they might have for it. Anyway, we call it the 0 line, and it is just the middle. Okay? And the nice thing about the 0 line, for sine, 3 of the points are on the 0 line. Okay, so that point, and that point are on the 0 line. And for cosine, 2 of them are on the 0 line. So knowing where the 0 line is going to be a big part of finding the points and, you know, generating properties and thinking about just what the function looks like. Okay. Okay, so that means our goal is to do this. For sine. Here we go. Find those 5 key points. And this is for the base curve. And then for cosine, what are the 5 key points? Where does it start? Good. So at the top, and then the middle, and then the bottom, and then the middle again, and then back to the top. So these are the 5 critical points. The requirement for us is that those are what we call lattice points. What is a lattice point? Yeah. Not in the middle. So, I mean, that's the fancy way of saying if I go down to the grid, where the grid lines meet. So I can't be here or here or here or anywhere like that. It's got to be where the grid lines meet. is what we call a lattice point. And one of the harder things of this is determining your x scale that you're going to count by so that they do fall on lattice points. But I'm going to try to give you a straightforward way as I can on how to do it. And there kind of are other ways of doing it. So if you are struggling, come in and ask as always, and we can talk about maybe some other strategies of how you could do it. The other thing is you can try it, and if it doesn't work, guess again, right? Like if you try pi by 6 and it doesn't work, try pi by 12. Like just make something smaller and see if that will work. So there's other aspects to it as well, a little bit, but that's essentially, you know, what we're going to go for. And then again, it's y equals a sine k x minus c plus d is the general equation. And the a, the k, the c, and the d are the values that we're going to look for to generate those properties. To find the 5 points, find the scale that's going to work, and then plot the points. And obviously, we're going to draw a curve through them when we actually do this. Any questions so far? We use this thing called the 5 key questions method. I don't know where it came from. I learned about it for the first time, I think, when I came to the school board at a different school, but I learned about it there. And it's really awesome and easy to use. There are other ways that other people do it that I think are more complicated. There are other questions that people ask anyway. You don't need to know any of that. You probably don't care. But, you know, this is the way that we do it. We call it the 5 key questions. It's more like 7.5 questions, quite frankly. But we call it this for whatever reason. And it is a good guide to how to do this. So if you haven't done this before or you haven't done it at this school, if you did it somewhere else, this might be new to you. But this is the method that we want to see. Generally on quizzes and tests, I don't necessarily need to see all the work. You should be showing the work because if you make mistakes, then I can give you part marks. But I am marking your final graph. So do you have to know that question 1 is what is the 0 line? No. I don't care about the exact order. I don't really care about the numbers. You're not memorizing that. But it is a straightforward step-by-step way of taking your equation and turning it into the properties to be able to graph. So trust me, just follow it and do it this way, okay? So here are the questions if you ever need to go back to them. Different teachers, even at this school, do them in a slightly different order. So if you did it in a different order last year, again, that's what I'm saying. That part doesn't really matter. This is the order that I do it. Start with the 0 line, and get the amplitude. And from there, I can get the max and the min, because we know that the max goes from the 0 line up the amplitude, and the min goes from the 0 line down the amplitude. And the max and the min are where some of these points occur. Where this one occurs, where this one occurs, where that one and that one occur. So we need to know the max and the min. Then we say, where does it start? That's our phase shift. What is the period? That will give us the end, so we know where our last point lands. And after you've done all of that, then you're going to go and work out your x scale. And after you've done that, you're going to try to graph it. And again, there's a couple of different ways of doing that. I'm going to show you the way that I do it. If you're struggling with it, come in and I can talk to you about other options. Okay? There are other ways of doing it that some people find easier, but we're not going to go over both of them, so, or all of them. Any questions so far? All right, let's try one. There's something off about this one. Does anybody see it? You might not. And quite frankly, it's not going to come up very often for us in this course, but what's wrong with the 3x? You got to factor it out. So we don't ask this of you very often, but if you look back at the original one, the k is factored out of the brackets, and that does have to be that way. So just in case it does ever come up, so what's that going to be? 3 pi over 12, which reduces to? Nice, pi by 4. We want the reduced version for sure. Okay? Now, what did I tell you is the most important thing when you're talking about graphs? It's overwhelming to look at that and say, I don't even know where to start. So break it down. What's the A value? What's the K value? What's the C value? What's the D value? Somebody give me one of them. A value is -2. Good. What's the K value? Like you're just picking numbers out of the equation, for goodness sakes, James. K is 3. What's the C value? A little bit careful with this one. Close? Huh? No, pi by 4 is closer. It's negative pi by 4. You got to flip the sign of this one. If you get that wrong, but you get your graph right, I'm not going to take marks off on that, so that's okay for me, at least, because the expectation is not that you're getting the right C value, it's that you're graphing it correctly. And we know that inside brackets, it has the opposite effect. So plus pi by 4 will be a shift to the left pi by 4, which means the C value is negative. And the D value is 1. D. And that's where you need to know this. Where's the A, the K, the C, and the D? And then you need to know what they tell us about the function. So 0 line. Is the D value. So 1. But I'm going to write it as an equation. Y equals 1. Again, this is kind of for you. So I'm not really worried about form here. That being said, I think if you're writing the equation of a line, you should always write it as an equation. So writing y equals 1 is better. Okay, but you know, it's not really a form thing because it's going to be about the graph. Question number 2, what is the amplitude? And it is 2. Thank you for not saying -2 because it's always positive. That would be an easy thing to do, and I just finished telling you if you said that was -2, I would take marks. I would take marks off of that. If it was a question where it says what is the amplitude of the graph in the picture or whatever, right? Like then that would be wrong. Then we're going to find the max and the min. And the max is the 0 line up the amplitude, and the min is the 0 line down the amplitude. Order there matters. You can't do it the other way around. Again, for me, it's a visual thing. I picture a graph starting at the 0 line up to the max, back to the 0 line, down to the min. So 1 plus 2 is 3. 1 minus 2 is -1. And if you do it backwards, you might get those backwards. And you might get your max to be -1 and your min to be 3. And that doesn't make any sense. So be careful. Hard to believe somebody might do that, but there are questions that come later where it happens. Okay? So be a little bit careful. If you want to make a little note, 0 line plus amplitude, 0 line minus amplitude is where those came from. Question number 3 is the start. Where does it start? This is supposed to be kind of an easy one. Negative pi by 4. The C value is just where it starts. What is the period? Who remembers the formula for period? Why would it be pi by 3? Divide what by the k value? So it is 2 pi divided by k. Good, which is 2 pi divided by 3. So it's 2 pi by 3. not pi by 3, but you were on the right track. Very good. 2 pi divided by k. That's how you find the period. We talked about that relationship when we looked at it the other way around. If you're finding the k value, k is equal to 2 pi divided by the period, which is just that rearranged, right? So 2 pi by 3, and then finally the end is the start plus the period, which is negative pi by 4 plus 2 pi by 3, which is negative 3 pi by 12 plus 8 pi by 12, which is 5 pi by 12. Your calculator can do this for you, if it can do fractions. Negative 1 over 4. So notice I dropped the pi. I just said 1 over 4. 1 pi over 4 is 1 over 4. Plus 2 over 3 gives me 5 over 12. So I know it's 5 pi by 12. You can put the pi's in too. Just why waste your time? Shift pi every time. Like, you don't have to. You can just know that part. That's not that hard, is it? I mean, you haven't done it yourself yet, but all you're doing is taking the a value and the c value. I mean, there's your a value, there's your c value. Like, you're just writing them out as their properties. That's doable. This is, to me, a great, like, step-by-step procedure of taking something that looks overwhelming. How in the world do you graph that thing? And breaking it down. I already know where the start is, because I know where the 0 line is, and I know where it starts, so I could find that point. I know where the max and the min are. Points are there. Like, I already know a lot about this. Got to get the scale. We're going to get to that next. But not too bad. Breaking it down. Okay, so x scale. By the way, I don't usually write out all this extra stuff like 0 line. I do usually write amplitude, but you could just put 2 there. I do usually write out max and min. That's just me. Again, my work has to be clear in case you're reading it. But I think writing max and min so you know which one is which is probably a good idea. I don't show all this work for the finding the end. I would probably just put it down. Even here for the period, I don't show the formula every single time. For the first one that we're doing together, I'm going to show that. But you know, you can kind of streamline all of this. And again, that part really is more for you. So you can kind of do it the way that you want to do it. Does that make sense? Okay, the next part is probably the most challenging. There's a little bit of memorization here. And everybody does it a bit differently. This is how I do it. First of all, I look at my critical points. And I'm going to find the distance between critical points. And to do that, I take the period and divide it by 4. Why 4? And somebody will ask the next day or something, or the next question that we do, well, how do I know to do 4? Because it's 4 every time. That's why.
Is this 4 spaces between critical points?
Very good. 1, 2, 3, 4. So when I divide it by 4, there's 5 points. There's 5 points, Mohammed. But that breaks it up into 4 equal lengths. So we want to divide by 4. So always divide by 4. 2 pi by 3 divided by 4 is what? 2 pi by 12. Whoops. Which is? Pi by 6. then we take our phase shift, and we have to compare it to our phase shift, and our phase shift was negative pi by 4. Technically, we don't even care about the negative part. We just care about the value, but to not be confusing, I will add that in. Okay? Good so far? Just like you need to know this formula for finding the period, 2 pi divided by k. You just need to know this is what you do. You need to know you take the period and divide by 4, get that result in lowest terms, and then you need to write out the phase shift and compare these two. Okay? You just need to know that. This might feel new compared to grade 11. You didn't have to do it, so why are we doing it now? Why are we overcomplicating things? Well, in grade 11, you might have a period of 45 and a phase shift of 60. So if I start my scale at 60 and count by 60s, 60, 120, 180, 240, and so on, well, my first point will work, but I can't count by 45s, can I? So if my next point is 45 degrees along, it's not going to be a lattice point. So if you had to match 60 and 45, what would you count by? 15. It's really easy to do. Harder to do when it's radians, unless you convert to degrees, which I guess you could. But it's a little bit trickier to come up with what do I count by that will have a pi by 4 on it, because I have to start there. And then also I can count by pi by 6s to get to the next points. So that's why we have to go through all of this. So our last thing that we do is we compare those. And it's actually kind of straightforward once you get it and you've done it a few times. You are just looking for basically a common denominator. So basically the lowest common multiple of 6 and 4, which is, no, that would be like the factor of it. We're going the other direction. So 12. So we're going with a bigger common denominator. If you were adding them together, it would be 12. Okay? So pi by 12 is the number that we're going with. Does that make sense? What is pi by 6 in degrees? 30. What is pi by 4 in degrees? 45. What is pi by 12 in degrees? 15. That's almost the same example that I gave you, right? If critical points happen every 30, but I got to start at 45, if you count by 15s, you'll get there. You'll hit every point. If I'm counting by 15s, I'll have my first one. I'll go 2 squares to get to my next point, because counting by 15, 2 squares would be 30. 2 more squares, 30. 2 more squares, 30. Is it right? That's easy in degrees. Little trickier in radians. So this is the counting in radians and the stuff that we've kind of been talking to and leading up to it. Any questions so far? There's one more part to this that I'm going to go over with you. And this is where maybe you could do things a little bit differently. And I think Mr. Newstetter does it a little bit differently from how I do it. So if you want to do it one way or the other, both are fine. But this is how I do it. Now that you've got all this done, you have to decide how many squares do you want pi by 12 to be. Okay? So you could make pi by 12 equal to 1 square, or 2 squares, or 3 squares, or any number of squares. And again, your goal is to make sure the graph isn't so stretched that the points go off the graph. And it's not so small that your graph looks like this. Point, 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 point. Okay, you can't do that. So you've got to stretch it out a little bit. Use as much of the grid as you can, kind of. Don't go overboard. You got to get all 5 points on the graph, and they have to be lattice points. If I have to go, if I'm counting by pi by 12s, and between my critical points is pi by 6, if I make pi by 12 1 square, how many squares are between my critical points? That's a hard question. Let me ask you a different way. If I'm counting by 15 and there's 30 between critical points, how many times do I have to count to get to the next critical point? 2. That's easy. Counting by 15 is 15, 30. 15, 30, 15, 30 every single time, right? 15, 30, 45, 60, however you want to think about it. And this is the same thing. So if I'm counting by pi by 12s, I got to go twice to get to pi by 6. So if pi by 12 is 1 square, I would have 2 squares between critical points. If pi by 12 is 2 squares, how many squares between critical points? 4. If pi by 12 is 3 squares, how many squares between critical points? 6. And then you get to choose which one to use, which will stretch it out nicely but not too far. I'm going to choose the middle one. And that's just my choice. 2 squares between critical points will be a very small graph. 4 squares will stretch it out a little bit better. 6, we tend to give you a big grid, so it's probably fine. But there are some famous questions in the homework where it has a large phase shift, so you have to make it a small graph or it won't fit. So you do have to think about this. The other thing you have to think about is you don't just put the axes in the middle of the grid. And then you got a phase shift all the way over here, and then 4 squares between critical points, and like you can't even fit anything, right? So there's a lot of little mucky details to think about in all of this. So just to clarify, you might want to write this down in case you look at this later and it's confusing. The 6 to the 12 was times 2. Okay, and then I picked this one, so it's times 2 again. And 2 times 2 is 4, which is what gave me the 4 squares between critical points. But if you're getting the fraction stuff, you can probably just kind of figure it out. Like I said, there is another way of doing it. Some people would say it's easier. I don't think it's a matter of easiness. I think it's a matter of just your comfort level with different things. If you can figure out how to do this, and most people can, holy cow, the graphing part is really easy. Okay, if you can get to this, it's almost trivial from this point. So, are you ready to graph? Things to consider. We have a phase shift to the left, so I also can't put my vertical axis right on the edge. I got to leave enough squares over here to fit the first point. I'm going 4 squares between critical points, and I'm going 4 times, so 16 squares. Well, we've got a lot more than 16 squares, so we're not going to be tight for space. I'm pretty sure we could have fit 6 in pretty easily as well. Okay, so let me see here. I got to go at least 6 squares to get to my starting point, I think. So if I start around here, I go 1, 2, 3, 4, 5, 6. So I am going to put, whoops, I lost it already. I'm going to pull out my ruler. Definitely be using a ruler when you're making these. So I'll put it somewhere right there. I think it should be totally fine. And then we're shifted up, which means I want my x-axis to be down a bit. The minimum is -1, so even if I'm kind of counting 2 squares, I only need a few squares down at the bottom, more squares at the top. Again, I don't want things to be crunched, but I also don't want to run out of space. So I'm going to do my vertical axis first. I'll call that 1. So I'm counting by 0.5s. 2, 3, 4. My rule is your scale has to go to or past each point. So our max is 3, so I have to count past 3. Okay, and then -1, -2. And our min is -1, so again, we're fitting the whole graph. Now you're going to want to watch here. I chose pi by 12 to be 2 squares. So there's 1 pi by 12. This is 2 pi by 12s, which is? Okay. Pi by 6. 3 pi by 12s, 4 pi by 12s, which would be 2 pi by 6s, which would be pi by 3. So 4 squares to count pi by 6s. 1 pi by 6, 2 pi by 6, 3 pi by 6, which is pi by 2, which is also 1 pi by 12, 2 pi by 12, 3 pi by 12, 4 pi by 12, 5 pi by 12, 6 pi by 12, 7 pi by 12, 8 pi by 12, what's 8 pi by 12?
2 pi by 3.
2 pi by 3. 9 pi by 12. 10 pi by 12, which is 5 pi by 6. We've gone way past our end, so we didn't even have to go that far. But that's the kind of counting that you have to do. Again, my expectation, I want to see a scale like this that has reduced radians on it and is counting by an equal distance. So it's a proper scale, like you used to in grade 9. If you're counting by 5s, you're counting all by 5s. You don't count by 5, then count by 3, then start counting by 5 again. 5, 8, 13, 18, like what the heck are you doing, right? It should be an even scale, but not everybody does it that way, so that's my expectation. And then going the other way. That is far enough to get us our start. It's a lot of prep work. I mean, we did this one slowly because it's our first one, right? But that took us a fairly long time. But it is a lot of prep work. But once you get all that done and you have labeled your scale and everything, the rest goes really fast. Are you all set? I always go back to the original question. Is it sine or cos? It's cos. Isn't that the worst thing? You do all this work and it's all perfect and it's all beautiful, and then you're supposed to be graphing cos and you graph sine. Now, you're going to get part marks if you've shown your work and I can get the properties out of that and I can see that what you did was correct. And it happens every year, at least to one person. For why? I don't know, because sine is the first one that you think of. So you graph sine. And what's the other thing that I have to think of?
It's reflected.
If it's reflected. So I always go back and look at those two things. It's cosine and it's reflected, so we start at the minimum. There's your cosine graph, starts at the max. Reflected would start at the min. Whoops. So our min, again, we've already got all this done. Our min is -1. Our start is negative pi by 4. So I'm starting at -1. Where is pi by 4 on my grid here?
It's a point in between negative pi by 3 and negative pi by 6.
Very nice. 1 pi by 12, 2 pi by 12, 3 pi by 12, which is pi by 4. Yeah. Okay, then I count 4 squares because that's what we calculated, that's what we chose. 1, 2, 3, 4, and I go to the 0 line, which is 1. Then I go 4 more squares, 1, 2, 3, 4, and I go to the max, which is 3. Back to the 0 line, 1, 2, 3, 4. Back to the minimum, 1, 2, 3, 4. There's your points. Now graph it. My computer keeps moving when I'm trying to do this. Yeah.
Isn't it supposed to move up 1? So our 0 line is actually at 1 and not at...
That is 1.
Oh.
Yes? I think so. But yes, and I like that you're thinking about that. I mean, yeah, exactly right. Now what am I going to do? Well, I'm going to do a few checks. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Good. 1, 2, 3, 4. Obviously, the up-downs don't have to be the same as the left-rights, but it happens to be that way. 1, 2, 3, 4. So those are right. Everything is symmetrical. Okay. And what is this point? One pi by 12, 2 pi by 12, 3 pi by 12, 4 pi by 12, 5 pi by 12. Bam. Where we were supposed to end. So you could call this the square counting method, where you calculate the number of squares between critical points. And once you do it, you just literally count 1, 2, 3, 4, next point, 1, 2, 3, 4, next point, 1, 2, 3, 4, next point, 1, 2, 3, 4, next point. There are other ways of doing it, one other sort of popular way. So if for some reason this isn't working out for you, talk to me and we can walk you through a different way of doing it. Any questions? Okay, we're going to do one more. First one we had to factor. We don't have to factor this one, so that part's done. What's our first step?
Determine the A, K, C, and D.
Thank you. So, I mean, it's up to you. Some people might say the 5 key questions. Yes, you're right, but I think your first step is write out A, K, C, and D. Write those out because that's always what we're talking about. So I want you to go ahead and do that, and if you can start to do questions 1 and 2 from the 5 key questions, you can do that as well. Okay, that's what I got for the A, K, C, and the D. Notice that it's x minus pi by 3, but C is positive pi by 3. It's a shift to the right this time. The C value matches the direction of the shift, not what is in the brackets. Question 1 is zero line. Question 2 is amplitude. Use those to find the max and min. If you haven't done that already, go ahead and try it. What's the zero line? Yeah.
Y equals
Negative 1. What's the amplitude? Go ahead.
y equals 1 over 3.
Yeah, just 1 over 3. Very good. So the max is going to be negative 1 plus 1 over 3, which is negative 3 over 3 plus 1 over 3, which is negative 2 over 3. Use your calculator for this kind of stuff, right? If you have to. 3 over 3 plus 1 over 3 would be 4 over 3, but it's negative 3 over 3. And then the min is negative 3 over 3 minus 1 over 3. There you go, negative 4 over 3. Then we do the start. Period. And the end. Give those a try. Okay, so the start is pi by 3. It's your C value. X minus pi by 3 is a shift to the right. So you're starting at positive pi by 3. So the whole graph is going to be in quadrant 4, right? Because everything is positive, negative, and to the right of the y-axis, like so it's all going to be over there. The period is pi. 2 pi divided by the k value, which is 2. 2 pi over 2 is pi. And the end is?
Oh, she's fine. It's all good.
So the start plus the period. 1 pi by 3 divided, oh, I'm frozen here, sorry. 1 pi by 3 plus 3 pi by 3 is 4 pi by 3. If you're very comfortable with this stuff, do it in your head. Not at risk of getting it wrong. You will have your calculator for the quiz and on the test for this. Okay, there's no more no calculator stuff until Unit 5, or Unit 6, sorry, I should say. So we're all good there. Get yourself a good calculator that can do fractions if you have to. Okay, and practice with it so you know how to do it. Okay, critical point. How do I find that? To do the x scale? Period divided by 4. Period is pi, so it's pi by 4. Phase shift is pi by 3. What's the common denominator? James? Pi by 12. 12 is the common denominator. When in doubt, pick pi by 12. If you're not good at this stuff and you're having a hard time, pi by 12 is a good guess. How many squares do I make pi by 12? Do I make it 1 square, 2 squares, 3 squares, 4 squares to stretch it out properly? if pi by 12 was 1 square, how many squares would I go? Huh? 3? How do you get that? Anybody?
Because you times the critical points by 3 to get 12.
4 times 3 is 12. So you take the denominator of the critical points, multiply by 3 to get 12. Now there are circumstances that are a bit more complicated, so watch for that in the homework. We're not going to do one like that today, but it will come up. So be careful. But for this one, it's straightforward. So 4 times 3 is 12. So you'd have 3 squares between critical points already. Pi by 4 is 45. Pi by 12 is 15. 15, 30, 45. You're counting 3 times. Right? All of this makes sense. This is where if you have to think in degrees, don't you dare put it on your piece of paper, but do it in your head is fine, if you have to. And memorize what the different ones are. Remember now that pi by 12 is 15, and you can kind of just think it through. Or you can say 1 pi by 12, 2 pi by 12, 3 pi by 12, which is pi by 4, so you've counted pi by 4 going 3 squares. So that's good enough. 3 squares is fine. If I double that to, if I make that pi by 12 2 squares, I'm already 6 squares between critical points. I think we have enough space to do that, but I'm not going to. So I'm just going to say pi by 12 is 1 square. Therefore, we have 3 squares between critical points. Do you see how you calculate that and then decide how many squares to make it? It has to be at least 1. But you could count over 2 squares to a pi by 12, or over 3, or over 4 to stretch it out. That's how this works. Okay. We have a shift down and a shift right and a small amplitude. We never go into the positives. So I'm going to have my axes like kind of crossing up here somewhere. So I keep lots of space that way and lots of space that way, kind of thing. And you might even in some cases want to sort of count out how many squares you need here and there. Like again, I said, it's kind of messy, mucky stuff. But you go ahead and make yours and I will make mine. This is the last one. Last one we were counting 2 squares to go to pi by 12. And if I did that twice, then I would get to pi by 6. In this case, we're counting 1 square to pi by 12. So 2 squares will be pi by 6. And then I can continue from there. I guess I don't have any space to even label 1 on the other side, but that's okay because we're not going that direction anyway. So you can keep going with that scale. Our end is 4 pi by 3, so I have to go at least to that or past it. So I just went 1 past it, and I can stop. You don't have to label all the way to the end. How am I going to count my y scale? I could do 2 squares per third. So let me see. That'd be 1/3, 2/3, 3/3, which is 1. 4/3, 5/3, and -4/3 is the minimum, right? So that would work. In this case, if you did 1 square or 2 squares, I'd be fine with either. So yeah, let's leave it at 2 squares. So this is 1, -1, sorry.
Pi by 3 and pi.
Did I miss one?
I think there is.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I did. Oh, 5 pi by 6. Thank you very much. Is that better? What was this last one? 3 pi by 2? 1, 2, 3, 4, 5, 6. Okay. What if I didn't catch that? If you're counting the proper number of squares, you're not going to end at the actual end. Or you're going to somehow try to force it, which is another way of doing things, and you're not going to have the same number of points between your critical points, same number of squares between your critical points. So something will be off. And that's an easy thing to happen when you're counting and labeling for that to happen. So, you know, if that happens, that's why you want to check how many squares between critical points, both up, down, and left, right. And you would catch a mistake like that. Very nice. Okay, hopefully you're with me now. Everybody's got their scale and everything drawn. What do we do before we start plotting points? Check if it's sine or cos, and if we have a reflection. It is sine. Sine starts at no reflection. Sine starts at the 0 line. And our 0 line is -1. Our start is pi by 3. Pi by 3 happens to be on the scale the way that I made it. We said 3 squares between critical points. And I'm going up to the max, which is -2 pi by 3, because we're not flipped. So 1, 2, 3, up to the max. That's -2 pi by, or sorry, 2/3, not pi by 3, -2/3. 1, 2, 3, back to the 0 line, to the minimum, which is 4/3. 1, 2, 3, back to the 0 line, 1, 2, 3. Our end was 4 pi by 3, so nailed it. Okay, and then go ahead and connect those. Folks, this is not a sine graph. Okay? It's got a curve through the points. Whoops, let me do it. Undo. Okay? It doesn't look like this. It doesn't have to be perfect, but you have to try. I like to find a point and kind of come out of it sideways. And come out of it sideways, and go into it sideways, and come out of it sideways, something like that. Like, that's just how I sort of think about it, because I'm not the best artist, if that helps you. Some people do weird things with sine, where they go like this. Well, that's wrong, because it should be coming out and going straight through. Right? So think about it a little bit. Look at your graphs as you draw them. Compare them to the ones that are in the solutions on your learning goals. Make sure that if I'm giving you any feedback, this doesn't look like sine, or if I'm circling parts of your graph, and writing something on it, that probably means it's not good enough, okay? And there's something about it you have to fix, and if you're not sure what it is, ask, okay? But that's it. 5 key questions, A, K, C, and D. Figuring out your X scale is probably the trickiest part, but once you've done all that pre-work, the graph comes together pretty easily. First time you do it by yourself might be a bit tricky, like a lot of things, okay? And it might take you a little bit longer. You got to push through that. You got to keep working at it. You'll get there. Think about the little details at the different steps that are things you memorize, the kind of formulas, dividing by 4, 2 pi divided by k, those little things. And if you break it down to step by step, it's pretty doable.